October 3rd, 2025. Right now, at this very moment, multiple spacecraft orbiting Mars are pointing their most sophisticated cameras at something that fundamentally should not exist according to everything we understand about physics and cosmic mechanics. An object currently streaming 150 kilograms of gas and dust into space every single second with absolutely zero recoil, zero thrust, zero consequence. Like watching a massive cannon fire continuously without any kickback whatsoever. A violation so fundamental and disturbing that when scientists first analyzed the data, their immediate assumption was that their multi-million-dollar instruments had catastrophically malfunctioned. They meticulously checked every sensor, every calibration, every possible source of error. The instruments were working perfectly. The data was accurate. The physics is what's broken, or rather, what we thought we understood about physics is inadequate to explain what we're witnessing. Harvard's Avi Loeb, the controversial astrophysicist who made international headlines by suggesting Oumuamua might be alien technology back in 2017, has rated this object a 6 out of 10 on his carefully constructed scale for potential extraterrestrial technological origins. That's 60% scientific confidence that this isn't natural, that we might be observing something artificial passing through our solar system right now. But that's not why you're here watching this video, reading these words, investing your time in understanding what might be the most significant discovery in human history. You're here because 2 days ago, on October 1st, someone claiming to work directly with the European Space Agency leaked something explosive on 4chan, of all places. Not a mainstream science journal, not a press conference, not through official channels, but anonymously on an internet forum known more for conspiracies and internet culture than legitimate scientific discourse. Yet the level of technical detail, the depth of frustration bleeding through every sentence, the specific insider knowledge that hasn't appeared in any public papers or press releases, all of it suggests this might be genuine, that we might be getting an unprecedented glimpse behind the curtain of official science into what researchers are actually seeing, actually thinking, actually terrified to discuss publicly because of career implications. The leaked post is technical, detailed, and deeply frustrated with institutional silence. They describe a formal working group that has spent months trying desperately to make this object fit into any known classification of natural celestial bodies, comets, asteroids, debris from planetary formation, anything that allows them to check the boxes and move on with conventional explanations. Quote from the leak: "This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us." Think about that phrasing for a moment. Cognitive dissonance, the psychological stress of holding two contradictory beliefs simultaneously. In this case, believing that your data is accurate and reliable while also believing that conventional natural explanations still apply, because if the data is correct and all indications suggest it is, then the natural explanations collapse completely under scrutiny. They talk about chemistry that literally shouldn't be possible under any known natural processes. Nickel tetracarbonyl, a synthetic industrial compound that we manufacture in refineries and laboratories using sophisticated metallurgical processes, is streaming off a rock that's supposedly billions of years old, formed in the cold reaches of interstellar space where such compounds simply cannot form naturally. Dust particles so strange, so far outside all expected parameters, that it took a full week of repeated recalibration before the research team would accept that the measurements were actually real and not some systematic instrumental error affecting multiple independent observation systems. And a mass problem so severe, so statistically impossible, that it breaks our entire understanding of how interstellar objects should be distributed. 33 billion tons, equivalent to a small mountain, compressed into roughly 3 kilometers of space. The statistical odds of finding something this massive before cataloging thousands of smaller objects first are so astronomically bad that either our fundamental models of galaxy-wide object populations are wrong by a factor of 10,000 or more, or this thing isn't random debris ejected from some distant dying solar system at all. But here's what makes this situation transition from merely anomalous to genuinely terrifying when you understand the full implications and timeline. In 26 days from right now, 3I/Atlas disappears behind the sun for nearly 2 months, creating the perfect observational blackout window where every telescope on Earth will be completely blind to whatever happens. Hidden from view during its closest approach to our star, during the period when it should be most active if it were a normal comet, during the exact window when any intelligent system would perform critical maneuvers to alter its trajectory and become gravitationally bound to our solar system instead of passing through and departing forever. And when this object finally reemerges in early December, sliding back into visibility in the pre-dawn sky, we'll know definitively if it changed course, because if it did, if there's any deviation from the purely gravitational trajectory that physics demands, then nothing natural can explain that. No amount of outgassing, no fragmentation event, no conventional mechanism can produce the velocity changes needed to stay in our solar system unless there's propulsion, unless there's intentionality, unless something is controlling this object's path. There's a theory, a hypothesis that sounds like pure science fiction ripped from the pages of a speculative novel, but actually explains every single anomaly we've observed with disturbing coherence and scientific rigor. The outgassing producing no thrust despite violent continuous emission. The synthetic chemistry appearing on an ancient interstellar wanderer. The thermal impossibility of staying cold while absorbing gigawatts of solar power. All of it fits if you accept one premise that challenges everything we think we know about what drifts through the darkness between stars. What if this object has its own internal engine, a power source that doesn't depend on the sun, that doesn't require external heating, that's been running continuously for billions of years, powered by something from the Big Bang itself, from the first microseconds when the universe was unimaginably hot and dense and the fundamental forces behaved in ways we can barely comprehend. And this hypothesis is testable, falsifiable, subject to scientific verification in ways that will either confirm or completely demolish it within the next 3 months. 2 specific predictions, both clear and unambiguous, both coming to resolution by early 2026 at the latest. First prediction. As 3I/Atlas recedes from the sun and moves into the cold outer solar system where normal comets become dormant and fade into invisibility, this object's activity will remain impossibly high, continuing to outgas and shine with brightness that violates every thermodynamic model we have for how passive bodies cool and become inert. Second prediction. If we point gamma-ray telescopes at this object's location and search for high-energy emissions that shouldn't exist around any natural comet, we'll detect a signal, a heartbeat, evidence of particle physics processes happening inside this thing that only occur in the most extreme astrophysical environments or in theoretical exotic matter we've never confirmed exists. This is 3I/Atlas, officially designated C/2025 S4, the third interstellar object humanity has ever detected passing through our solar system, and the first one that's made serious scientists question privately whether they're looking at a comet or something pretending to be one with sophisticated camouflage. By the end of this comprehensive investigation, you'll understand in technical detail why some researchers are losing sleep, why the trajectory looks deliberately designed rather than randomly determined by gravitational chaos, why the timing of its arrival and planetary encounters is too perfect to be coincidental, and what happens when accumulated data keeps stubbornly refusing to cooperate with comfortable explanations, because the walls we've built around this mystery are starting to crack. And the true shape of what we're observing is beginning to show itself whether we're prepared to accept the implications or not. Before we dive deep into every shocking detail, every leaked observation, every theory that mainstream science doesn't want to discuss in public forums where reputations are made and destroyed, I need you to do something absolutely critical right now that will determine whether this information reaches the people who need to understand what's happening above our heads. Hit that subscribe button and turn on all notifications, because this story is developing in real time with new data arriving daily from observatories worldwide. The October 3rd Mars flyby observations are being processed as you watch this. The December reemergence will provide trajectory data that could rewrite human history. You absolutely cannot afford to miss the follow-up coverage when those results are released and analyzed, because this might be the biggest scientific discovery of our lifetimes, the moment when humanity definitively learns we're not alone in the universe, or at minimum that our understanding of cosmic physics requires fundamental revision. This content represents hundreds of hours of meticulous research, careful analysis of technical papers written in dense academic language, synthesis of data from dozens of independent sources, and conversations with scientists who agreed to speak only on background, because openly discussing these possibilities could end careers and destroy professional reputations built over decades. Understanding this material at the level I'm about to present it will permanently change how you see the night sky, how you think about Earth's place in the cosmos, how you evaluate claims about anomalous phenomena that don't fit comfortable categories. So leave a like right now to push this video to more people through YouTube's recommendation algorithm, because this information is too important to remain buried in the margins of scientific discourse where only specialists encounter it. That engagement, those likes and comments and shares, tells the algorithm this matters, that real people care about real science and real mysteries that threaten to overturn established paradigms. And I want you to comment below with your location, the time where you are, and your honest initial reaction to what I'm about to present, because that interaction helps me understand my audience and helps build a community of people who care about following evidence wherever it leads rather than clinging to comfortable assumptions. Now let's get into the leaked data that's making established scientists question everything, starting with the fundamental physics violation that should be impossible but keeps appearing in every observation. Chapter 1. The recoilless howitzer firing in the void. Something is happening that violates Newton's third law, one of the most fundamental principles in all of physics, so basic and so universally confirmed that we don't even question it anymore. For every action, there is an equal and opposite reaction. When you fire a gun, the bullet flies forward and the gun kicks backward. When a rocket expels exhaust gases, the rocket accelerates in the opposite direction. When a comet releases jets of gas and dust from sublimating ice, the comet experiences thrust that gradually alters its trajectory over time in measurable, predictable ways. This is absolute, universal, inviolable physics that has been confirmed billions of times across every possible scenario, from molecular collisions to galaxy interactions. Except 3I/Atlas is violating it continuously, dramatically, undeniably, and nobody in official channels wants to acknowledge how disturbing that really is when you think through the implications. The James Webb Space Telescope, the most advanced infrared observatory humanity has ever built, observed 3I/Atlas on August 6, 2025, using instruments so sensitive they can detect the chemical composition of objects billions of miles away with incredible precision. What Webb found was staggering in its implications. The object is venting approximately 150 kilograms of material every single second, a combination of carbon dioxide gas, dust particles, trace amounts of water vapor, and that mysterious nickel that shouldn't be there. 150 kilograms per second might not sound like much until you do the math and realize that's 9,000 kilograms per minute, over 500,000 kilograms per hour, more than 12 million kilograms per day of material continuously streaming off this object at velocities measured at roughly 400 meters per second based on spectroscopic Doppler shifts. That's enormous, violent, sustained mass loss that should be producing equally enormous and sustained thrust on the object itself, pushing it, steering it, altering its trajectory from a purely gravitational path in ways that accumulate over days and weeks into measurable deviations that orbital mechanics calculations can predict with precision. Every active comet humanity has ever studied shows this effect without exception. Halley's Comet, probably the most famous periodic comet, experiences measurable non-gravitational acceleration every time it approaches the Sun, documented across centuries of observations dating back to ancient Chinese and Babylonian astronomical records. When Edmund Halley first calculated that various historical comet sightings were actually the same object returning periodically, he had to account for perturbations, slight deviations from pure Keplerian orbital mechanics caused by outgassing thrust. Modern observations with precise radar tracking and high-resolution imaging have quantified this effect down to fractions of millimeters per second of velocity change, tiny but real and cumulative. Comet Hale-Bopp, the spectacular Great Comet of 1997 that was visible to the naked eye for months and became one of the most observed comets in history, showed non-gravitational acceleration that astronomers meticulously tracked and modeled. The jets were so powerful and so asymmetric that the comet's rotation period actually changed measurably over the course of months as the rocket effect from one-sided outgassing altered its spin. 2I/Borisov, the previous interstellar visitor detected in 2019, also showed clear non-gravitational acceleration consistent with normal cometary activity, exactly what you'd expect from an icy body warming up near the Sun. The magnitude of the effect matched theoretical predictions based on the observed gas production rates and the estimated mass of the nucleus. Everything checked out, everything made sense, everything fit into the comfortable framework of comet science developed over centuries of patient observation and increasingly sophisticated modeling. 3I/Atlas shows almost nothing, vanishingly small deviation from a purely gravitational trajectory that's at least 2 orders of magnitude smaller than it should be given the observed outgassing rate. This isn't a claim from the anonymous leak. This is published in peer-reviewed literature by Richard Warwick, Avi Loeb, and Peter Verez in a paper that analyzed 4,022 positional observations collected by 227 observatories worldwide between May and September 2025. They calculated the object's trajectory with extreme precision using astrometric measurements accurate to tiny fractions of an arcsecond, then searched for any residuals, any deviations from the gravitational path that would indicate non-gravitational forces acting on the object. The upper limit they derived was 0.028 arcseconds of deviation across months of continuous observation. When you translate that into physical acceleration using the object's known distance and velocity, it corresponds to less than 1.5 meters per day squared of non-gravitational acceleration. For an object venting 150 kilograms per second at 400 meters per second, simple momentum conservation says the acceleration should be roughly 100 times larger than that, maybe more depending on exactly how you model the geometry of the outgassing and the mass distribution. The physics simply doesn't work unless you make the object's mass enormous, so massive that the momentum carried away by 150 kilograms per second becomes negligible compared to the object's total inertia, like trying to push a freight train by throwing baseballs at it. The leaked post addresses this head-on with brutal clarity and mounting frustration. It feels like a mistake in the data until you've checked it 100 times with all available instruments from multiple countries and research groups using completely independent methodologies. The object is venting about 150 kilograms of gas and dust every single second according to spectroscopic measurements that multiple teams have confirmed. We see it clearly in emission lines, in thermal models, in direct imaging of the coma and tail brightness. Yet it does absolutely nothing to the object's trajectory. The non-gravitational acceleration is effectively zero within measurement uncertainty. It's like watching a howitzer fire a shell continuously with absolutely zero recoil. No smoke indicating propellant. No bang indicating explosive release. No gun rocking backward as the shell departs. It's a constant violent event with no consequences whatsoever. And that is a disgusting violation of basic physics that every undergraduate learns in their first mechanics course. Let that image sink in for a moment. Really visualize what's being described here. A massive artillery piece firing continuously without any recoil, without moving at all, without showing any evidence that momentum conservation applies. That's not unusual, that's not anomalous, that's impossible in our current understanding of how the universe works at the most fundamental level. The only way the physics works, according to the anonymous insider who claims direct access to the working group's internal deliberations and models, is if the object has truly staggering mass crammed into an impossibly small volume. Quote, "The only way the physics works, the only way Newton's third law isn't being violated in some reality-breaking fashion, is if the object has the mass of a small moon crammed into a space no more than 2 to 3 kilometers across based on the best size estimates from brightness and thermal modeling. The lower models, the most conservative estimates that don't assume any unusual albedo or thermal properties, give us a minimum mass limit of 33 billion tons, which immediately creates a second and arguably worse problem that breaks our statistical models of interstellar object populations. Finding a mountain of that mass on an interstellar trajectory passing through our solar system now, before we've detected hundreds of thousands of smaller objects first, is statistically impossible unless our models are catastrophically wrong. Think about what 33 billion tons means in tangible terms that humans can grasp. That's roughly the mass of a solid sphere of iron 3 kilometers in diameter, a metallic asteroid of significant size. But this isn't a metallic asteroid, it's outgassing like a comet. It has volatiles on its surface. It's producing a visible coma and tail. So somehow this object has to reconcile being dense enough to resist recoil from massive outgassing while also having ices and dust that sublime and create the observed activity. Those requirements are in tension, they pull in opposite directions, and finding a configuration that satisfies both becomes increasingly contrived the more carefully you examine the constraints. The poster continues with even more disturbing implications. Our surveys with next-generation automated detection systems like the Vera Rubin Observatory have only just started becoming fully operational in the last year or two. To find an object this massive this soon, literally within the first few years of having detection capabilities sensitive enough to spot these things, means the galaxy isn't just occasionally dotted with debris from planetary system formation as our models suggested. It's absolutely swarming with massive interstellar objects that we've been completely blind to until now. The statistical models we've used for decades must be wrong by a factor of 10,000 or more in terms of mass distribution, which means our entire picture of what gets ejected from solar systems during their formation and evolution is fundamentally and grotesquely flawed at the most basic level. And here's where the post gets truly unsettling, this object isn't debris at all, isn't a natural remnant of some distant planetary system's chaotic early history. It's something else entirely, something our models never anticipated because we've been looking for the wrong things in the wrong places with the wrong assumptions about what's out there. That ellipsis, that pause before the alternative explanation, speaks volumes about the cognitive dissonance the writer is experiencing, the tension between what they're trained to believe about how science works and what the data is actually telling them. And that, the post concludes with obvious frustration and perhaps fear, is the quiet and terrifying conclusion that we are being actively discouraged from discussing openly in professional settings where our statements become part of the permanent record and can affect future funding and career advancement. Pause here and let that implication settle fully before we move forward into even stranger territory. If the mass estimate is correct, if 33 billion tons is the minimum value required to make the physics work, then either we've been fundamentally wrong about how interstellar space is populated with objects of various sizes, or we're looking at something that didn't form through natural planetary system processes. Both options are uncomfortable, both require major revisions to established understanding, and both have profound implications for how we interpret everything else we're about to examine in this comprehensive investigation. We'll return to this mass problem repeatedly because it underlies almost every other anomaly, but first we need to understand the chemistry, because what's actually in the gas streaming off this object is where things transition from merely puzzling to genuinely impossible under any natural formation scenario we can construct. Before we continue deeper into the scientific nightmare that is 3I/Atlas, I need you to understand why your engagement right now, at this specific moment, matters more than you might realize for the broader scientific community and public understanding. Leave a comment below right now telling me what you think is happening with this object, whether you believe we're looking at something natural or something else entirely, because that interaction signals to YouTube's algorithm that this content is valuable and should be promoted to more viewers who care about real science happening in real time. The scientific establishment operates largely in isolation from public awareness, publishing papers in specialized journals that cost hundreds of dollars to access, presenting findings at conferences that only credentialed researchers attend, creating an information barrier that keeps most people completely unaware of how often our models are challenged by observations that don't fit. This investigation is my attempt to break through that barrier and show you what's actually happening in the scientific trenches where data meets theory and sometimes theory loses badly. Now let's talk about the chemistry that's making researchers question whether they're observing natural processes at all, starting with a synthetic industrial compound that absolutely should not exist on a rock that's been drifting through interstellar space for billions of years at temperatures barely above absolute zero. Chapter 2. The Industrial Chemistry Signature Streaming into Space. In July and August 2025, the Very Large Telescope in Chile, one of the premier astronomical observatories on Earth featuring an array of massive mirrors that can be combined for incredible resolving power, pointed its UV-visible Echelle spectrograph at 3I/Atlas and detected something that made the research team question their instruments for a solid week before they'd accept the results as genuine. Nickel atoms, pure atomic nickel, were streaming off the object in measurable quantities, showing up as clear, unmistakable emission lines in the ultraviolet spectrum at wavelengths that correspond exactly to nickel transitions when the atoms are excited by solar ultraviolet light. Nickel at every observation epoch, consistently present, never absent, with production rates that increased dramatically as the object approached the sun following a steep power-law relationship. Now you might think, okay, so there's nickel on the object, lots of asteroids and comets have metallic components, what's the big deal? The big deal is temperature and basic thermodynamics. Nickel is a refractory metal with extremely high melting and boiling points. You can't just heat a chunk of nickel with sunlight and expect it to sublimate like ice turning to vapor. Nickel's melting point is 1,455 degrees Celsius. Its boiling point is 2,913 degrees Celsius. At the distances where 3I/Atlas was observed, roughly 2 to 3 astronomical units from the sun depending on observation date, surface temperatures would be somewhere between -100 and -50 degrees Celsius, cold enough to freeze carbon dioxide solid, far below the point where metallic nickel could possibly sublimate directly from solid to gas. Yet there it is, atomic nickel in the spectrum, undeniably present, requiring some mechanism to get solid nickel atoms off the surface and into the gas phase around the object where ultraviolet sunlight can excite them and make them emit those characteristic wavelengths that show up so clearly in the spectroscopic data. The anonymous leak doesn't hedge, doesn't dance around the implications, doesn't use careful diplomatic language. It names the compound explicitly: nickel tetracarbonyl, chemical formula NiCO, 4, one nickel atom bonded to 4 carbon monoxide groups in a symmetric tetrahedral geometry. Quote from the leak: "You look at what's actually in the gas streaming off this thing and it gets so much worse than just detecting nickel atoms. We're seeing pure atomic nickel streaming off at a rate that scales absurdly steeply with solar illumination, following a power law that's something like the 9th power of the solar flux, which is insanely sensitive. This isn't gradual warming causing slow sublimation like water ice turning to vapor as a comet approaches the sun. It's a switch, an on-off response where tiny changes in solar heating produce massive changes in nickel production. The nickel emission is insanely sensitive to sunlight in a way that suggests photochemical dissociation, molecules breaking apart specifically because UV photons are hitting them and directly causing bond breaking. There's only one chemical compound that makes sense, that explains everything we're seeing, including the temperature sensitivity and the power law scaling. Nickel tetracarbonyl, a synthetic chemical we use in industrial refining through a process called the Mond process. It explains everything, especially why there's no iron showing up proportionally with the nickel as there should be if this were natural cosmic material. But it's not a naturally occurring compound in space. It's manufactured. What the hell is a synthetic industrial chemical doing on a rock which we think has been drifting through interstellar space for billions of years since being ejected from some distant planetary system? That question hangs there, unanswered, because there is no comfortable answer that doesn't require either exotic special pleading or uncomfortable conclusions about what this object actually is. Let's talk about nickel tetracarbonyl in detail so you understand exactly why its presence, if confirmed, would be so profoundly disturbing to conventional explanations. At room temperature and atmospheric pressure on Earth, Nickel tetracarbonyl is a colorless liquid that looks like water but is extraordinarily toxic, far more dangerous than carbon monoxide alone. It was discovered in 1890 by a chemist named Ludwig Mond who was researching nickel metallurgy and found that carbon monoxide gas reacts with impure nickel metal under specific conditions to form this volatile compound. That discovery led to the Mond process for purifying nickel, still used industrially today. You take impure nickel containing iron and other contaminants, expose it to carbon monoxide at moderate temperatures and pressures, and nickel tetracarbonyl forms preferentially because nickel happens to have the right chemical properties to bind carbon monoxide in this stable configuration. The iron doesn't form an equivalent compound under the same conditions, or if it does form iron pentacarbonyl, it's less stable and less likely to survive. Then you heat the nickel tetracarbonyl vapor in a separate chamber. The compound decomposes thermally, carbon monoxide is released, and pure nickel metal deposits on the chamber walls. It's an elegant metallurgical technique, invented through human ingenuity, used in refineries and chemical plants, not something we've ever detected forming naturally in terrestrial geology or in space environments accessible to our instruments. The compound is volatile, boiling at 43 degrees Celsius, cold enough that it could exist as a solid or liquid on the surface of an object in the outer solar system and certainly in interstellar space where temperatures are just a few degrees above absolute zero. And critically, it's photosensitive, meaning it breaks apart when exposed to ultraviolet light which the sun emits in abundance. UV photons hit the molecule, the carbon monoxide groups detach one by one or all at once depending on photon energy, and you're left with free nickel atoms and carbon monoxide gas. This would perfectly explain the observations from 3I/Atlas in ways that no natural mechanism proposed so far can match. Nickel tetracarbonyl on the surface, warmed slightly by sunlight to temperatures where it starts to sublimate and enter the gas phase, forming a thin atmosphere around the object. The vapor drifts away from the surface into the surrounding coma, where there's more space and less shadowing from the nucleus. Ultraviolet photons from the sun hit the molecules. Photodissociation occurs rapidly on timescales of seconds or minutes. The molecules break apart. Atomic nickel is released and immediately shows up in UV spectra with those characteristic emission lines that multiple telescopes have now detected independently. And because this is a light-driven process, photochemistry rather than thermal chemistry, the production rate would be extraordinarily sensitive to solar illumination following a steep power law as the flux increases. A small change in distance from the sun produces a large change in UV flux, which produces an enormous change in dissociation rate, which produces the observed steep scaling of nickel emission with solar distance. Every detail fits, the chemistry is coherent and self-consistent, the physics makes sense. There's just one gigantic problem that nobody can explain away. Nickel tetracarbonyl doesn't form naturally in space under any conditions we know about or can reasonably propose. Carbon monoxide is abundant in space, absolutely. It's one of the most common molecules in interstellar clouds and protoplanetary disks, formed when oxygen atoms combine with carbon in cold environments where more complex chemistry is inhibited by low temperatures. Metallic nickel also exists in space, incorporated into dust grains in various silicate and metallic phases depending on formation conditions around different types of stars. But bringing them together to form nickel tetracarbonyl requires specific conditions. Gaseous carbon monoxide in contact with metallic nickel surfaces at temperatures and pressures where the reaction is favorable, typically a few hundred degrees Celsius and elevated pressure compared to the near vacuum of space. These conditions might exist briefly in the very early stages of planet formation in certain regions of protoplanetary disks where temperatures and densities are higher, but even if nickel tetracarbonyl formed there, it's unstable over geological timescales, especially when exposed to the radiation environment of interstellar space. Cosmic rays, high-energy particles from supernovae and other violent events, continually bombard interstellar material, breaking apart complex molecules over millions and billions of years. An object traveling through the galaxy for the timescales required for interstellar transit, hundreds of millions or billions of years depending on ejection velocity and distance traveled, simply shouldn't have intact nickel tetracarbonyl on its surface unless it's being produced actively, continuously, by some internal process rather than being ancient material from its formation. That's the leap the anonymous insider is suggesting, that 3I/Atlas isn't carrying fossil chemistry from billions of years ago but is generating exotic compounds as byproducts of whatever is happening inside, like exhaust from an engine rather than sublimation from ancient ices. Then there's the iron problem, or more accurately, the lack of iron problem, that makes this even more puzzling when you dig into the details of cosmic elemental abundances. In normal comets, in meteorites, in essentially every sample of cosmic material we've ever analyzed in detail, nickel and iron appear together in ratios that reflect their cosmic abundances set by stellar nucleosynthesis. Both elements are formed in similar nuclear fusion processes deep inside massive stars, burning through their fuel in the final stages before going supernova. They're expelled together when those stars explode, mixed together in the ejecta that eventually condenses into dust grains and gets incorporated into new planetary systems forming from enriched material. The solar abundance ratio is roughly 1 nickel atom for every 15 to 20 iron atoms depending on exactly which data source you use, and this ratio is remarkably consistent across different types of cosmic objects because they all formed from the same well-mixed reservoir of heavy elements synthesized in previous stellar generations. So when you look at a comet or an asteroid spectroscopically and detect metals, you expect to see nickel and iron together in roughly that cosmic ratio. Maybe there's some variation, maybe certain minerals preferentially incorporate one over the other by a factor of 2 or 3, but order of magnitude differences are extremely unusual and demand explanation. 3I/Atlas shows extreme nickel dominance that gets worse, more anomalous, the more carefully you measure it. In the early observations from July, when the object was still relatively far from the Sun at around 3 astronomical units, nickel was detected clearly in the spectrum, but iron was absent below detection limits, invisible in the wavelengths where iron emission should appear if it were present in normal proportions. As the object approached closer to 2.6 astronomical units in late August and September, iron finally appeared in the spectrum, but even then the nickel-to-iron ratio remained far higher than normal, roughly an order of magnitude off from cosmic abundances or what we see in other comets. The VLT team documented this carefully in their published paper, noting the anomaly but offering only tentative explanations about how maybe different minerals preferentially release different metals, or maybe there are spectroscopic effects they're not accounting for properly. The anonymous leak is far more direct. If both metals are present in the object's bulk composition, as they should be if this formed naturally from cosmic material, why does nickel sublimate so freely and efficiently while iron stays locked up even at higher temperatures when more volatiles should be releasing? The only explanation that makes chemical sense is selective compound formation. Nickel tetracarbonyl forms preferentially under conditions where iron doesn't form an equivalent volatile compound, or where iron pentacarbonyl, if it forms at all, is much less stable and breaks down more readily so it doesn't accumulate in observable quantities. The chemistry is selective, preferentially releasing nickel and leaving iron behind. But that requires an active chemical environment, not just passive ice sublimation dragging along random dust grains. It requires carbon monoxide interacting with metallic surfaces under conditions that favor this specific organometallic chemistry. And that requires either an incredibly specific set of formation conditions that we've never seen or encountered before in any other object, or it requires ongoing chemistry happening right now inside the object, which means there's an active chemical factory operating in there producing these compounds as needed rather than releasing ancient frozen material. Either option is deeply uncomfortable for the standard comet narrative that treats these objects as essentially inert dirty snowballs that formed billions of years ago and haven't changed chemically since except through slow radiation-induced alterations to their surfaces. Now let's discuss the dust, because the polarization data, which measures how light scattering off particles becomes polarized in specific directions, reveals something equally strange and equally hard to explain with conventional dust grain models. When light from the sun reflects off dust particles in a comet's coma and tail, the reflected light becomes partially polarized, meaning the electric field oscillates preferentially in certain directions rather than randomly in all directions. The degree and angle of polarization depends sensitively on the size, shape, and optical properties of the dust grains doing the scattering. Astronomers have studied this for decades across hundreds of comets and asteroids, building up a database of what normal polarization looks like for typical solar system objects with typical dust compositions. Silicate grains, a few micrometers across, roughly spherical or maybe somewhat elongated, produce a specific range of polarization signatures. Carbon-rich grains, fluffy aggregates of smaller particles, produce a different but still predictable signature. You measure the polarization at different wavelengths and different phase angles, the angle between the Sun, the object, and Earth, and you can infer a lot about what kind of dust you're looking at without ever collecting a physical sample. 3i/Atlas produced polarization measurements so far outside the normal range that the research team initially thought their instruments had malfunctioned or their data reduction pipeline had bugs they hadn't caught in testing. According to the leak, and the dust it's shedding is just as fundamentally messed up as the chemistry and the physics. We measure how light reflects off these particles, specifically measuring the polarization, which tells you about grain size and texture and composition. Every comet, every asteroid we've ever studied in the decades since polarimetry became a standard technique, they all fall within a certain predictable range that reflects typical dust properties from rocky or icy material sublimating and fracturing in normal ways. This thing's data comes back so far off what's expected, so far outside the error bars on our models that account for measurement uncertainty and natural variation, that our project director insisted we were screwing up the observations for the better part of a week until we repeated the result multiple times with different telescopes on different nights under different observing conditions. They checked everything, recalibrated all the instruments, verified the data reduction software wasn't introducing artifacts, ran test observations on normal comets and asteroids to confirm they were getting expected results for objects with known properties, and then reobserved 3i/Atlas. Same answer every time. The polarization at a 90-degree phase angle, where the Sun-object-Earth angle is perpendicular and polarization effects are typically strongest, came back as negative 2.1%. That specific number means the polarization is perpendicular to the scattering plane rather than parallel as it should be for normal dust. And the magnitude suggests particle properties that are extremely unusual. The only way to explain these numbers according to both the published papers and the anonymous insider is if the dust grains are fundamentally different from anything we normally see. Quote from the leak, "The only way to get these polarization values, the only models that can fit this data when you run through all the possible grain size distributions and compositions and shapes, is if the dust grains are something else entirely compared to typical comet dust. Not normal silicate sand grains, not water ice crystals, not even the carbon-rich fluffy aggregates we see in some primitive comets and asteroids. Large, incredibly complex particles with internal structure. Black, meaning high absorption of light rather than reflection, making them thermally efficient at absorbing solar energy. And porous as smoke, meaning they have huge amounts of empty space inside their structure, like aerosol particles or soot from combustion, rather than solid grains chipped off a rocky surface. Think about what that description implies. Typical comet dust is simple, small grains maybe a few micrometers across, relatively compact solid particles with straightforward optical properties. But large complex particles with high porosity, that's fundamentally different. That's the kind of structure you get from processes that build particles atom by atom or molecule by molecule in gas phase chemistry, like combustion creating soot, like chemical vapor deposition in industrial processes, like photochemical reactions in planetary atmospheres forming haze particles. Those are processes that create intricate structures with fractal geometry, huge surface area to volume ratios, complex absorption and scattering properties. They're not the kind of dust you get when ice sublimates off a frozen rock and lifts simple rocky debris into space through mechanical forces. And if the dust is black, highly absorbing rather than reflecting, it would heat up very efficiently when exposed to sunlight, reaching temperatures significantly above the equilibrium temperature you'd calculate for normal dust, which brings us to the next massive problem that the anonymous insider describes with mounting frustration. The thermal energy budget for 3i/Atlas doesn't balance, doesn't close, leaves a huge surplus of energy that has to go somewhere but apparently isn't going into the expected places that standard comet models assume. Quote from the leak. Then there's the heat problem, which gets worse the more carefully you calculate the energy flows. The thing is cold, far colder than it should be for an object at that distance absorbing that much sunlight with that surface area. It's absorbing gigawatts of raw solar energy when you do the straightforward calculation of taking the cross-sectional area that intercepts sunlight and multiplying by the solar flux at its distance, enough power input to run a small city's electrical grid continuously. We calculate the energy budget trying to account for where all that absorbed solar power goes, and there's a massive surplus that doesn't add up. That absorbed heat has to go somewhere according to basic thermodynamics. Energy is conserved. It should be driving off enormous plumes of water vapor, sublimating massive amounts of ice as the latent heat of sublimation absorbs all that incoming energy and converts solid ice to gas. But the water isn't there in the spectrum in anything like the quantities needed to balance the energy. The ratio of carbon dioxide to water is 8:1, completely backwards from normal comets where water dominates. So the energy isn't going into water sublimation. It should be heating the interior, raising the temperature until thermal radiation balances the absorbed solar input. But spectroscopic observations of surface temperature indicators suggest it's staying cold, locked at temperatures that shouldn't be sustainable with that much power input. It's like pointing a blowtorch at an ice cube and watching it refuse to melt, just sitting there cold and solid while absorbing kilowatts of thermal power that have to be going somewhere but aren't showing up in any of the places we look for heat output. Energy doesn't just disappear. That violates the first law of thermodynamics, which has even more experimental support than Newton's third law. So either the thermal models are wrong in some fundamental way that nobody has identified despite decades of experience modeling comet thermophysics, or there's a heat sink, something absorbing energy internally without raising surface temperature. What could possibly do that? In normal matter, in passive objects made of rock and ice, there aren't many options. You can conduct heat into the interior if you have high thermal conductivity, but that just moves the problem elsewhere and eventually the interior heats up and starts radiating. You can have endothermic chemical reactions that absorb energy, but those are limited by the amount of reactants available and they eventually reach equilibrium. You can sublimate volatile ices, which is a huge heat sink, but as we've established, the water vapor isn't there in sufficient quantities to account for the absorbed power. The anonymous poster suggests the object has found a way to actively regulate its thermal load. The object has found a way to either dispose of enormous thermal energy in wavelengths or mechanisms we're not measuring, or to regulate its surface temperature, keeping it locked at a specific low value despite varying solar input, which implies control rather than passive thermal physics, implies a system managing heat flows rather than a dead rock responding passively to external heating. That word again, regulate, suggesting active management, intentional control, engineering rather than natural thermodynamics. If that's true, if the surface temperature is being artificially maintained at low values despite high energy input, that requires either a remarkably efficient cooling system or, as the insider eventually proposes, an internal power source so much stronger than solar heating that the sun becomes almost irrelevant to the object's thermal state. The post concludes this section with a statement that ties all these thermal observations together into a coherent but deeply unsettling picture. The gigawatts of power from the sun that we can directly calculate from geometry and solar flux measurements are a trivial external variable to a monstrous object with a mass of 33 billion tons or more that has its own internal power source operating continuously for billions of years. It radiates solar energy away passively through thermal emission like any inert rock would, maintaining a cold surface temperature through efficient re-radiation, because the sun is simply not part of its internal life cycle or energy economy. The sun didn't create it, doesn't power it, doesn't control its activity level. Its own power source, an internal engine independent of solar heating. If you accept that premise, Everything else starts to make sense in ways that are internally consistent and physically coherent, even though the premise itself seems absurd at first encounter. The recoilless outgassing makes sense because the gas is being produced isotropically from internal heating, not from localized solar heating of one hemisphere. The exotic chemistry makes sense as byproducts of whatever internal process is generating energy. The thermal indifference makes sense because solar heating is negligible compared to internal power output. All the pieces fit together into a complete picture that works, that's self-consistent, that makes testable predictions. There's just one small problem. The internal power source would have to be something we've never confirmed exists, something that sounds more like theoretical physics speculation than observational astronomy. And that's exactly what the anonymous insider proposes next, a hypothesis so wild it should be dismissed out of hand except for the uncomfortable fact that it explains every single anomaly better than any conventional alternative while making specific falsifiable predictions that we can test within the next few months. Here's where this investigation takes a turn into territory that sounds like theoretical physics fantasy, but is actually grounded in serious scientific research published in prestigious journals by respected physicists who wouldn't risk their reputations on pure speculation. The anonymous insider, after laying out all the observational problems and chemical impossibilities, proposes something that initially sounds absurd but becomes more compelling the more you examine how well it explains every anomaly simultaneously. Quote from the leaked post. There's a hypothesis, an explanation that sounds like it came from a science fiction novel written by someone who actually understands physics, that actually explains everything we're seeing without requiring any violations of known physics or special pleading about exotic formation conditions. Cue balls, quark nuggets, compact objects made of exotic matter that formed in the first microseconds after the Big Bang when the universe was incomprehensibly hot and dense and the fundamental forces operated under conditions we can never replicate in laboratories. These are theoretical objects that physicists have predicted might exist based on our understanding of particle physics and cosmology, but we've never confirmed their existence observationally because we didn't know what signatures to look for and we weren't looking in the right places with the right instruments. Before you dismiss this as wild speculation disconnected from observational evidence, understand that this hypothesis was developed by serious physicists including Avi Loeb working with colleagues who specialize in particle physics and cosmology, published in peer-reviewed journals where claims are scrutinized rigorously, and make specific testable predictions that observations over the next few months will either confirm or definitively rule out. Cue balls, sometimes called quark nuggets or strange matter nuggets depending on the specific theoretical framework, are hypothetical objects consisting of quarks in exotic states that we don't normally encounter. In the everyday matter that makes up stars and planets and people, quarks are confined inside protons and neutrons, bound together by the strong nuclear force into stable configurations. But in the extreme conditions of the very early universe, in the first microseconds after the Big Bang when temperatures exceeded trillions of degrees, quarks existed freely in what physicists call a quark-gluon plasma. As the universe expanded and cooled, most of this plasma condensed into normal matter following the familiar path to protons and neutrons and eventually atoms. But some theoretical models predict that small pockets of the quark-gluon plasma could have survived, forming stable droplets of exotic quark matter that persisted as the universe cooled around them. These objects, if they exist, would have truly extreme properties that make them unlike anything else in the cosmos. Incredibly dense, far denser than normal atomic matter, because quarks can pack much more tightly when they're not confined inside protons. Extremely massive for their size, giving them huge gravitational binding energy that makes them effectively indestructible. And potentially very long-lived, surviving for billions of years because they're in a different, more stable energy state than normal matter, like supercooled water that refuses to freeze because it's in a metastable state below its freezing point. The hypothesis for 3I/Atlas goes like this, and I'm quoting directly from the anonymous insider who appears to have access to internal working group discussions that haven't been published publicly. A cue ball, a relic quark nugget from the Big Bang, 3 kilometers across, containing 33 billion tons of exotic matter compressed into a volume far smaller than normal matter could occupy. It's been drifting through the galaxy for billions of years since the early universe, cold and dark and nearly invisible except for occasional interactions with normal matter. As it wanders through interstellar space, it very slowly accumulates a coating of normal material on its surface, dust grains and molecules that stick through electrostatic attraction or weak chemical bonding, building up a layer of ice and rocky debris over geological timescales. Think of it like a seed crystal in a supersaturated solution, gradually accreting material from its environment. After billions of years traveling through the galaxy, collecting material from molecular clouds and stellar winds and planetary debris, the cue ball has built up a surface layer thick enough that from the outside it looks like a comet or asteroid, covered in frozen gases and dust that mask its exotic interior. That accretion layer, that surface coating of normal matter accumulated over cosmic timescales, is what we're actually observing when we point telescopes at 3I/Atlas. The ices that sublimate under solar heating, the dust particles that scatter sunlight and produce polarization signatures, the molecules that break apart and produce emission lines. All of that is just the skin, the outermost superficial layer concealing something far stranger underneath. Now here's where it gets interesting and the physics starts to make sense of observations that otherwise remain inexplicable. Cue balls, according to the theoretical models worked out by particle physicists studying exotic matter, should slowly decay through quantum processes, converting exotic quarks back into normal particles and releasing energy in the process. The decay rate would be incredibly slow, imperceptible on human timescales but significant over billions of years, producing a steady trickle of energetic particles and radiation from the object's interior. That internal energy generation creates a heat source completely independent of solar heating, a power supply that's been running continuously since shortly after the Big Bang and will continue running for billions more years until the exotic matter is exhausted. This internal heat conducts through the object and reaches the surface layer where it drives chemistry and sublimation from the inside out rather than from the outside in like normal comets. Solar heating is almost irrelevant, a trivial external perturbation compared to the massive internal power source. That explains why the object's activity level stays so high and why the thermal budget doesn't balance when you only account for solar input. The sun isn't powering this object's activity at all. It's just illuminating gas and dust that are being produced by completely different processes happening in the exotic matter core. The internal heating also explains the chemistry, particularly the formation of nickel tetracarbonyl that seems so impossible under normal conditions. As the interior of the object maintains warm temperatures from radioactive-like decay of exotic matter, carbon monoxide and other volatile molecules in the accreted surface layer can undergo reactions that would never occur in normal interstellar conditions. Carbon monoxide produced from various organic molecules in the icy coating can percolate inward through pores and cracks, reaching regions where temperatures are warm enough for chemical reactions to proceed efficiently. When CO encounters metallic nickel grains also present in the accreted dust layer, it can form nickel tetracarbonyl through exactly the same Mond process chemistry we use industrially, but occurring naturally inside this object because it has the necessary warm temperatures that solar heating alone couldn't provide. The compound forms continuously in warm interior regions, migrates outward through diffusion and vapor transport, reaches the cold outer surface where it condenses as liquid or solid, and then when solar UV hits it during daytime, the molecules photodissociate, releasing atomic nickel into the coma. Meanwhile, iron, which doesn't form equivalent volatile carbonyls as readily or forms less stable compounds, stays locked in the dust grains and only appears in the spectrum at much lower levels when those grains are heated enough to directly vaporize metal, explaining the anomalous nickel-to-iron ratio that conventional models struggle with. The exotic dust properties also make more sense in this framework. If the surface layer is being processed by internal heating over millions of years, cooked slowly from below by steady heat flux from the exotic matter core, you'd expect complex chemistry to occur that wouldn't happen on normal comets where internal temperatures stay frozen. Organic molecules can undergo thermal cracking and recombination, forming complex polymers and carbon-rich structures similar to petroleum coke or combustion soot. Highly porous materials with fractal structure and strong light absorption exactly matching what the polarization measurements indicate. The dust isn't simple rocky debris lifted mechanically by sublimating ice. It's the product of complex pyrolysis chemistry occurring over geological timescales in the warm interior of an object that maintains its own temperature through internal power generation. That produces dust with properties we've never seen before because we've never observed the products of this particular chemical environment. Everything fits together into a complete coherent picture where each observation supports and reinforces the others rather than creating additional contradictions that require further special pleading. And then there's the mass, that 33 billion tons compressed into 3 kilometers that breaks all our statistical models if this is supposed to be normal debris from planetary system formation. But if it's not debris, if it's a primordial relic from the Big Bang, then the statistics completely change. We don't know how many cue balls formed in the early universe or what their size distribution should be. Those quantities depend on details of particle physics during phase transitions in the first microseconds that we can't directly observe and can barely calculate theoretically. The fact that we found one massive object before cataloging thousands of smaller ones isn't statistically impossible anymore. It just means our assumptions about interstellar object populations were wrong because we were only thinking about objects formed in planetary systems, not objects formed in the Big Bang that have been wandering the galaxy since before stars existed. The detection rate makes sense if there are huge numbers of these primordial relics out there, far more abundant than we imagined, drifting through interstellar space, waiting to occasionally pass close enough to a star for us to notice them when their surface activity lights up under solar heating. The anonymous insider continues with the most testable aspects of this hypothesis, the predictions that will either confirm or destroy this explanation within months. This hypothesis makes predictions, specific falsifiable predictions that aren't vague or adjustable but are concrete and testable with observations we're planning or could plan. First, the activity shouldn't drop off as this thing recedes from the sun like every normal comet ever observed does. Normal comets become dormant in the outer solar system when temperatures drop and ices stop sublimating, fading gradually into invisibility as they move beyond Jupiter's orbit. But if the activity is driven primarily by internal heating from exotic matter decay rather than by solar heating, then it should remain high even as the object moves outward and solar flux decreases. We can test this by continuing observations through December and into 2026 as 3I/Atlas reaches its closest point to the Sun and then starts moving away again. If it stays bright and active far longer than a normal comet would, if it's still producing gas and dust at significant rates when it's beyond 4 or 5 astronomical units where comets normally shut down, that's strong evidence for internal heating. That prediction is concrete and will be resolved definitively by early to mid-2026 simply by continuing to observe the object as it recedes. Either the activity drops following the expected thermal model for solar heating, or it doesn't and we have to explain sustained activity at distances where the sun can't possibly be driving it. The second prediction is even more specific and more dramatic. Second prediction: if we point gamma-ray telescopes at this thing's location and look carefully for high-energy photons, we should detect gamma rays at energies consistent with exotic matter decay. Quark nuggets slowly annihilating their exotic matter should produce measurable gamma-ray emission through various particle physics processes, pions decaying into photons, electron-positron annihilation, various decay chains from heavy quarks transitioning to lighter ones. The flux would be small, challenging to detect, but it should be there if the internal power source is really exotic matter decay as this hypothesis suggests. The Fermi Gamma-Ray Space Telescope has the sensitivity if we integrate long enough and know exactly where to look. That observation could be done, should be done as soon as possible before the object disappears behind the sun and we lose our chance for months. That's a smoking gun test. Normal comets produce zero gamma rays. Nothing in their chemistry or thermodynamics generates high-energy photons at MeV energies. If 3I/Atlas shows a gamma-ray signature, even a weak one, above the background noise, that's essentially impossible to explain with conventional comet models and strongly supports exotic physics. And if it doesn't, if gamma-ray observations come back with nothing above background despite sensitive searches, then the cue ball hypothesis takes a major hit and we're back to trying to construct some elaborate natural explanation that accounts for all the other anomalies. Now you might be thinking this is all extremely speculative, borderline pseudoscience, taking a few strange observations and spinning an elaborate story that invokes exotic physics we've never confirmed. And you'd have a point. Healthy skepticism is essential in science to prevent us from accepting extraordinary claims without extraordinary evidence. But consider the alternative. Every conventional explanation proposed so far requires multiple independent coincidences and special circumstances to account for different anomalies. Maybe there's exotic interstellar chemistry we've never seen that forms nickel tetracarbonyl naturally somehow. Maybe there's a peculiar thermal structure that explains why the energy budget doesn't balance. Maybe the dust formed through some unique process we haven't thought of. Maybe the trajectory and mass are just unlikely but possible statistical flukes. Each one individually might be barely plausible if you stretch your assumptions enough, but together they strain credulity beyond the breaking point. The cue ball hypothesis, as wild as it sounds initially, has the virtue of explaining everything simultaneously with one unified framework. All the anomalies become natural consequences of a single exotic assumption, that this object has an internal power source from exotic matter decay, rather than requiring multiple separate exotic assumptions to explain each anomaly independently. This is actually how paradigm shifts happen in science historically. When accumulating observations don't fit the established framework and require increasingly elaborate epicycles of special assumptions to accommodate, sometimes the simpler explanation is to question the framework itself and consider that nature is more diverse than our models anticipated. The discovery of neutron stars followed exactly this pattern. Before they were confirmed observationally in the late 1960s through pulsar observations, the idea that stars could collapse into objects so dense that electrons and protons merge into neutrons seemed absurd to many astronomers, exotic physics that pushed the boundaries of credibility. But theoretical predictions from nuclear physics said they should exist, and eventually observations confirmed they did exist, and now they're a standard part of astrophysics textbooks. Cue balls might be following the same path from theoretical speculation to confirmed reality, and 3I/Atlas might be the observation that forces us to take the hypothesis seriously and test it rigorously rather than dismissing it as too weird to be true. The anonymous insider concludes this section with a statement that captures the frustration of scientists who see where the evidence is pointing but can't say it publicly without risking professional suicide. The refusal to publicly discuss this possibility, to even mention it as a hypothesis worth testing when it fits the data better than anything else we've proposed, that's what drove me to leak this anonymously. We're supposed to follow the evidence wherever it leads, but there are invisible lines we're not supposed to cross in public discourse because certain ideas are too uncomfortable for the field to handle. Suggesting that an interstellar visitor might be artificial or exotic in ways that challenge our understanding, that's career-ending if you're wrong and barely career-helping if you're right because you'll forever be known as the person who made wild claims. So we talk about these possibilities privately, in closed meetings where there's no record, but publicly we hedge and use careful language that doesn't commit to anything specific. And that's wrong. That's a betrayal of what science is supposed to be. If the data supports an exotic explanation, we should be shouting it from rooftops and designing observations to test it rigorously, not burying it in caution and institutional cowardice. That frustration, that sense of moral outrage about institutional failures, that rings true in ways that manufactured leaks don't. This person genuinely believes they're doing the right thing by going public with information that's being suppressed or downplayed by official channels. Before we move to the trajectory analysis and the timing coincidences that make this whole situation feel orchestrated rather than random, I need you to engage right now if you're still following this investigation, because we're about to enter the final section where everything comes together into a conclusion that's either the most important scientific discovery in human history or the most elaborate misinterpretation of anomalous data ever constructed by pattern-seeking minds. Comment below, the math checks out, if you've understood the cue ball hypothesis and you're ready to see how the orbital mechanics supports or challenges this framework. Because what comes next involves celestial mechanics and gravitational calculations that reveal just how improbable this object's path through our solar system really is when you examine the statistics carefully. Chapter 4: The Trajectory That Shouldn't Be Random. Orbits don't lie. Celestial mechanics, the mathematics governing how objects move under gravity, is arguably the most precisely tested and confirmed science humanity has ever developed. We can predict planetary positions centuries into the future with accuracy measured in seconds of arc. We can navigate spacecraft to distant planets using gravitational assists calculated years in advance. We can detect planets orbiting other stars by measuring the tiny wobbles in stellar motion caused by gravitational tugs. The math works, always, without exception, because gravity is extremely well understood and objects in space follow predictable paths determined entirely by gravitational forces plus any non-gravitational forces like rocket thrust or comet outgassing that we can usually identify and model. So when multiple independent teams calculate an object's trajectory and find something that has only a 1 in 500 chance of being random gravitational dynamics, that's not a suggestion. That's a loud alarm bell screaming that something unusual is happening and demands careful investigation. 3I/Atlas approached our solar system from a specific direction in space, from a point in the constellation Draco in our northern sky, traveling at a specific velocity of about 26 kilometers per second relative to the Sun's rest frame. That velocity is important because it tells us this is definitely an interstellar visitor, not a solar system native. Objects bound to our Sun, planets and comets and asteroids that formed here, have orbital velocities that are always less than the escape velocity for their distance from the Sun, the minimum speed needed to break free of solar gravity. At large distances where interstellar objects typically arrive, the solar escape velocity is only a few kilometers per second. Something traveling at 26 kilometers per second is moving far too fast to be gravitationally bound. It's not from here. It came from somewhere else, somewhere in the galaxy, traveling through interstellar space for millions or billions of years until gravity happened to steer it toward our solar system where we could detect it with our telescopes that scan the sky every night looking for asteroids and comets. Now, pure chance alone determines that some interstellar objects will approach closer to the Sun than others. That's simple statistics. If you have thousands or millions of these things wandering the galaxy, some tiny fraction will pass near enough to various stars to be potentially detectable if the timing is right and there are observers looking. But the specific path that 3I/Atlas is following through our solar system, the exact geometry of its trajectory relative to the planets, that's where statistics become uncomfortable and coincidence feels strained. The object's closest approach to Mars, its perihelion distance from the Sun, its departure angle, all of these orbital elements combine into a configuration that looks less like random gravitational dynamics and more like a carefully planned grand tour hitting multiple targets of interest. It passes within 18 million miles of Mars, close enough for detailed study by Mars orbiters, closer than many spacecraft missions are designed to approach. Then just 1 week later it reaches perihelion at roughly 0.9 astronomical units from the Sun, well inside Earth's orbit, at exactly the time when Earth is on the opposite side of the Sun, unable to observe it directly, creating a perfect observation blackout. Then it departs the inner solar system at an angle that brings it relatively close to Jupiter months later, where yet another spacecraft, ESA's JUICE mission en route to Jupiter's moons, will have an opportunity to observe it from a different angle with different instruments. Richard Warwick and Avi Loeb published a detailed statistical analysis of this trajectory in their paper covering the non-gravitational acceleration measurements. They asked a specific quantitative question. If you randomly drew orbital elements from distributions representing typical interstellar objects entering the solar system from random directions at typical relative velocities, What fraction of those random orbits would pass as close to both Mars and Jupiter as 3i/Atlas does? They ran Monte Carlo simulations, generating millions of synthetic orbits with randomized parameters within reasonable ranges, and calculated encounter distances for each one. The result? Only about 0.2% of random interstellar trajectories, 1 in 500, come as close to both planets as 3i/Atlas does. That's a p-value of 0.002, statistically significant by any reasonable standard. In normal scientific parlance, if you're testing a hypothesis and your p-value is less than 0.05, you reject the null hypothesis and conclude something non-random is happening. We're seeing a p-value that's an order of magnitude lower, stronger evidence that this trajectory is unlikely to be purely random gravitational dynamics without any guidance or targeting. Now, to be absolutely clear and scientifically honest, 0.2% probability doesn't mean impossible. Unlikely things happen all the time when you conduct enough trials. That's basic probability theory. If 1 million interstellar objects pass through the galaxy and we happen to detect the 1 in 500 that has an interesting trajectory, that's not evidence of design, that's just selection bias. We notice and pay attention to the unusual ones while ignoring the 1,000 boring ones that don't come near anything interesting. So you can't point to this trajectory alone and declare it must be artificial. That would be premature and statistically naive. But you also can't ignore it either, especially when it's combined with all the other anomalies we've been discussing. The strange chemistry, the impossible thermal budget, the weird dust properties, the recoilless outgassing, and now a statistically unusual trajectory, all pointing toward the same uncomfortable conclusion that this might not be random debris wandering through space by pure chance. The anonymous insider addresses this directly and discusses the debate happening within the working group about how to interpret the orbital statistics. The trajectory analysis is where opinions within our working group split most sharply into factions that can't reconcile their views. One camp says the trajectory is statistically interesting but not definitive, that we're seeing selection bias because we only pay attention to the unusual visitors while ignoring the boring ones, and that invoking targeting or intentional trajectory design is premature without stronger evidence than a 1 in 500 probability. Fair enough, I understand that perspective and it's scientifically defensible. The other camp, growing larger as more data accumulates, says we need to seriously consider the possibility that this trajectory was chosen deliberately to maximize scientific observation opportunities while minimizing risk. It passes close to Mars for detailed observation when spacecraft are positioned perfectly to observe it. It reaches perihelion when Earth can't watch, maintaining privacy during its most active period. It exits at an angle that brings it near Jupiter for another observation opportunity. If you were an intelligence planning an observation mission into an inhabited solar system, trying to gather data while remaining somewhat ambiguous about your nature, this is exactly the trajectory you'd choose. Close enough to be noticed and studied, far enough to maintain distance, timed perfectly to control what gets observed and what remains hidden behind solar glare. If you've made it all the way to this point in this investigation, through all the technical details and leaked revelations and hypothesis evaluation, then you understand why this matters so profoundly regardless of which explanation ultimately proves correct. Either we're observing the most anomalous natural object ever detected, something that will rewrite our understanding of interstellar chemistry and object populations and force us to expand our models of what's possible in cosmic environments, or we're observing something that challenges everything we thought we knew about humanity's place in the universe and whether we're alone. Both possibilities are scientifically valuable. Both advance human knowledge. Both justify the excitement and urgency that astronomers worldwide are feeling even if they're not expressing it publicly in ways that capture media attention. Now I need you to do something critical to ensure this information reaches the people who need to understand what's happening above our heads. Comment below. December will reveal everything. If you're committed to watching for updates when those critical trajectory measurements come in, because this community of engaged, informed viewers is how we push back against institutional information control and demand transparency about discoveries that affect all of humanity. Leave your like right now to tell YouTube's algorithm this content matters and should be promoted to more people who care about real science and real mysteries. Subscribe and turn on all notifications because when the December observations are released, when gamma ray results are published, when this story develops in ways that either confirm or challenge the leaked hypothesis, you want to be here for the analysis and discussion. This is potentially the biggest story in human history unfolding in real time, and mainstream media is ignoring it because it doesn't fit comfortable narratives and requires technical knowledge to understand properly. We're filling that gap, providing the depth and detail that this story deserves. And your engagement ensures this information doesn't disappear into algorithmic obscurity. Share this video with anyone who cares about space, about science, about the possibility that we might not be alone in the universe or that natural phenomena might be far stranger than we imagined. We're building a community of people who value evidence over authority, who follow data rather than consensus, who demand intellectual honesty from scientific institutions that have become too cautious and too political. And watch the next video that's appearing on your screen right now where I dive into the history of anomalous interstellar visitors including Oumuamua and Borisov and why the pattern we're seeing suggests this is just the beginning of a wave of discoveries that will transform how we understand our cosmic neighborhood. The universe is speaking to us through objects like 3I/Atlas, sending messages across the unimaginable distances between stars, and we're finally developing the technology to receive and decode those messages with sufficient detail to understand what they're telling us. What we learn over the next few months might comfort us or terrify us, might confirm our loneliness or herald our introduction to a much larger cosmic community, might validate our physics or reveal that reality is far stranger than our current models capture. But learn we will. And that learning process is what makes us human, what drives us forward as a species, what ensures our future reaches toward the stars rather than staying trapped on one small world assuming we know everything already. The data will decide. The evidence will reveal the truth. And we'll be here to analyze it honestly and present it clearly, following wherever the science leads regardless of how uncomfortable the destination might be. Thank you for investing your time and attention in this deep investigation into what might be the most significant astronomical discovery of our lifetime. Thank you for your patience with technical details and complex physics and statistical arguments that require careful thought rather than quick consumption. This is how science should be communicated, thoroughly and honestly with appropriate uncertainty, acknowledged and extraordinary claims treated with appropriate skepticism while remaining open to extraordinary evidence. If you found value in this analysis, if you learned something that changed how you think about this discovery and what it might mean, then share it widely and help build a community that values understanding over entertainment, depth over sensationalism, evidence over speculation. Until next time, keep watching the skies, keep questioning assumptions, keep demanding transparency from institutions that serve the public interest, and keep following the evidence wherever it leads because the universe has secrets to reveal and we're privileged to live in an era when revealing those secrets becomes possible through instruments and methods previous generations could never have imagined. Clear skies and see you in December when the truth about 3I/Atlas finally emerges from behind the sun.